No worries. I can see that the YouTube live session is coming. There's a bit of latency. It's still saying 3 minutes and 5 seconds. That's all right. Okay. Hey everyone, thanks for joining in. I think we got some uh, good representation over here. For people who are still making their way to the session is hybrid. It's both online as well as in person. The session is on level 18, 324 Queen Street. If you're still on your way, it's on level 18, 324 Queen Street. Today's session is about building reliable and secure Kubernetes environments using Open Policy Agent. Building compliant environments are a key part of what we do on a day-to-day basis. This session is being presented by Mark Foley, who's a senior solution engineer at VMware. Mark has had decades of experience, especially in the Kubernetes world. Um, uh, and I will get it over to Mark to kick us off and start through the session. Thanks, Mark.
policy and OPA into Kubernetes. The other thing it does, as well as more natural Kubernetes integration, is it introduces this concept of a constraint template and a constraint. And effectively, I'm going to show you this in a bit more detail, but what it does is it allows us to create these, effectively what they are Rego templates. So we create a Rego template and they're parameterized. So we can use exactly the same logic to apply different constraints. And if you're a little bit confused, hopefully I'm about to remove that confusion. So here's an example, and we're going to see more of these as we go through. So here's a very simple example constraint, and there's a couple of things in here. The metadata for that constraint template will define the parameters that are required. And in this case, it's actually very simple. We just need to provide an array of keys, right? So those keys represent the labels that we want. The Rego there is just going to check. See? I thought there was a moment there, and luckily it wasn't. So the Rego there is going to check that whatever object that we're checking has those labels associated with it. And again, I'm not going to go too much detail on the Rego. You actually get a long way in OPA without actually having to know too much about Rego, and I'll explain more about that a little bit later. So this is our template, right? We can apply this to our cluster. So this is a custom resource definition in Kubernetes. We're using Gatekeeper. We apply it to our cluster. Nothing happens. It's just in our cluster. Nothing will be enforced. Nothing will be checked or anything like that. It is just a template. Then what we're able to do is define constraints that utilize that template. So here's a constraint definition. So basically what this constraint definition does is it will point to the constraint template it uses, and it will provide a few different parameters. One of those parameters is the list of labels that are needed. The other parameter is what is the Kubernetes object that this applies to. So in this case, we're saying, I want all namespaces to make sure they have the label, the HR label, right? So that's one instantiation of a constraint. But then we can actually create other constraints using that same template. So here's another constraint, slightly different. In this case, we're saying we want this constraint to apply to pods and ingress controllers. And in this case, we want all our pods and ingress controllers to have some labels that define both business unit and owner. So it's much more modular, much more reusable. All these things are custom resource definitions, so they're kind of native to Kubernetes, much easier to use and apply. So that constraint template construct is really handy, really useful, and it just means that these policy engines become much more usable in a Kubernetes environment. So that's probably enough theory, I think. What I want to do now is go into my environment and start walking through a couple of use cases that are, they're not really real world, but they're kind of heading in that direction. Now, I am running on my laptop, so I'm just using Docker Desktop. So this is one of the nice things about OPA. It's pretty lightweight. It'll happily run on a desktop Kubernetes environment. I'm also going to use Octant. So for those of you who aren't familiar with Octant, this is a VMware open source project. So you can go and grab it today. A really nice way to visualize what's going on in the Kubernetes cluster, and also handy for troubleshooting and things like that. So I've already installed OPA on this cluster. I'm not going to show you that. It's really straightforward. It's just a Helm chart. So literally single command. I've never had any issues deploying it. It's not a lot of gotchas or anything I can give you there. Generally, it'll just go straight onto the cluster, and that should be fine. What you can see here is that in this particular cluster, what I've also done is prior to the session, I've actually gone and put a number of different constraint templates on. So the templates are there already. And remember what I said earlier, template by itself is not going to do anything, right? It's not going to modify the behavior of the cluster at all. To actually start to put some policy on there, I'm going to need to do some constraints. So let's start off by looking at a really simple constraint. So the first constraint I want to look at relates to namespaces. So if I have a look at this particular cluster, what you'll see here is there's a whole bunch of namespaces with all wonderful names like prod test 1, prod test 3, test 978. So obviously someone's been going hog wild in here. I've got no idea who those belong to, except for this one where someone specified an owner tag. Right now, that's as the owner of this cluster, I think that's a good idea. I would like to know who those namespaces belong to. So what I want to do is put a policy on this cluster that says, hey, if you create a namespace, you need to define an owner. So the constraint template already exists in this particular Kubernetes cluster. So let's have a look at that constraint template now. Let's see if I can find it. Yep, so here's my template. So as I said, I've already applied this, right? And this is a slightly more complex template. So it's doing a few different things, but again, similar sort of thing, right? Can be applied to any object in this case. The parameters it's taking, there's a few parameters it takes, asks for a message, right? So if this constraint gets violated, what message do you want to give the user? It also asks for an array of objects, and those objects are going to be the key, so what label we want, and also a regex expression. So that regex defines the format of a label because I basically want a URL definition of the owner. Then what we see here is some Rego. There's basically, effectively, it's a bit more complex than that, but there's a couple of different rules here. So one rule checks for the presence of the labels. So are the labels there? The next rule, this one here, goes and checks, okay, well, the label's there. Does the value match the regex that I've provided, right? Now, we're going to talk a bit more about this later. I just copied this, right? So there's the Gatekeeper project has some demos in it. This is from a demo. There's also some other resources online where you can go and get a lot of really good example templates. That's why I said earlier, you can actually go quite a long way with Open Policy Agent without actually having to get too deep into learning Rego. So you know, it is fairly easy to get started with. So I want to go and apply a constraint that I mentioned earlier around labels and namespaces. So if we just go to my terminal here. Right. So here's my constraint, which is this one here. And you can see there, though, again, I'm defining the object constraint applies to, namespaces. I'm giving the message. So this is what message is going to be given to a user if they try and violate that constraint. And then I'm specifying that we need to have the key owner and that regex needs to be in there. So the value needs to match that regex. So let's go and apply that constraint. And as I say, it's a CRD, so we can apply it as normal. Right, so that constraint's now in there. Now, if I just try and go and create a namespace without that label, so I'm not going to be allowed, right? We've violated the constraint. Oh, that was, sorry, that's my phone, people. Unlike some people, though, I have put my phone on silent. Sorry. We violated that constraint and that operation hasn't been allowed. So let's have a look at what happens when we try and put a namespace in that's compliant. So I've prepared one earlier. So I've got this little YAML file here, which is my namespace, and I have the owner label and a value that matches that Rego. So when I go and create that namespace, no problem, right? Met the constraint, all fine. What about all the stuff that's already there? So all the namespaces that are already there. what happens if I go and try and modify one of those? So let's go and modify one of the existing namespaces and maybe add a label to it. So and then so this is an existing namespace, doesn't have the owner label, so it's not compliant, and we're going to try and modify it, right? We're going to try and add a label to it. Right? Can't do it. Right? And the reason I can't do it is it's not compliant. So for someone to be able to keep working with that particular namespace, they're going to need to get it into a compliant state. Now, what you might want to do is you might want to go and find all those non-compliant objects. In this case, it's not a big deal, right? You know, there's only a few namespaces. It's probably pretty trivial to go and work that out. But you know, if you've applied policy to all the pods in a cluster, and it's a big cluster, but that's something you might want to chase down. One of the nice things about Gatekeeper, and one of the things that adds above sort of plain old OPA Kubernetes integration, is it has an audit function. So what will happen is when you apply policy, by default, audit is turned on. So every 60 seconds, it will go and take those policies and apply them, and it will produce an audit, some audit results for you. A few different ways you can grab that audit result, but the way I am going to show you is it actually just gets appended to the YAML definition in the cluster. So if I go back to Octane, you can see here that here's my custom resources. Again, we see all our templates, but now we have a constraint that I've just created. I can go and drill into that. And the first thing you'll notice is when I look at that constraint, you'll see one of the fields that get added to the status. And you can see here, it's detected 12 violations, right? So that's part of the audit functionality. So we know right away there's 12 violations. Again, have a look at the YAML. I can see just appended on the end are a list of all the namespaces and the other objects that have violated this policy, right? So you'll see here, namespace, the name of the namespace, and any message that is generated by the audit. So that functionality is there by default. So it's a nice way of going and picking that up. I think there's some API capability as well that you use to pull that audit out, but this is a nice simple way of going. If you want to turn this off, you can as well. So that's basic Gatekeeper, right? We've just gone and applied a constraint. We've done the normal configuration, which is the hard checking, the enforcement of constraints. That's not necessarily what you always want to do, right? That's slightly unfriendly to go and apply that to an existing cluster. You know, if you're able to just create namespaces at random one day and not able to do it the next, that might not make you that popular. So one of the things we might want to do is maybe ramp up the level of policy that we're applying in there. So I'm going to delete that particular constraint. So, and I'm going to apply a new one. And the new constraint is going to be this one here, which is basically identical to the other one, right? So exactly the same constraint, but the thing I've added is this, the enforcement action. So by default, the enforcement action is deny, which is what we just saw, right? Just don't let that happen. Now I'm saying the enforcement action is warn. So what it means is when a user goes and does something that they're not allowed to do, they'll get a warning message, but the event will go through. The other enforcement action you put on there is audit. So no warning, no deny, but it will appear in those audit results. So, you know, if you're sort of ramping up your level of policy on a cluster, start with audit and go and review the results, and then you can put a warning on, and then you go through and deny. So this pretty much does what you expect it to do, right? We're going to go and apply it. Right, so that constraint's now on there, but if I go and create a namespace, I get the warning, but the namespace still gets created anyway. So nice, simple example, and goes through a reasonable range of functionality of OPA and Gatekeeper. I just want to go through and have a look at a couple of other example constraints that are sitting in this. I'm not going to show them, but I just want to talk about some of the considerations around using something like OPA. So let's say this is from the Gatekeeper demo project, and there's some quite sort of real world constraints that are sitting in there, constraint templates that you might want to use. There's one there. Pull that up. There's one there around probes, right? So, this will allow you to specify what probes must be provided when you deploy a pod. So a good one to have in there, and a lot of people use this. There's another one in there around the repositories, container repositories that are allowed. And this is an interesting one, right? So this is the constraint template, and what it's going to do is it allows you to specify which repositories you're allowed to deploy from. So, if you try and deploy from a public repository, for instance, you don't want to do that. This is one of the ways you can control that. So quite nice. What you see here is two rules. And the reason there's two rules is that there are actually different types of containers in Kubernetes. When we had version 1 Kubernetes, we just had the concept of container. Then we introduced init containers. So we actually have to have two rules, one for the actual container, and now we have another one for the init container. This particular constraint template is actually no longer valid for the latest version of Kubernetes, because now we have a concept called ephemeral containers. So we actually need another rule here to handle ephemeral containers. And this is one of the considerations for using OPA, right? It knows nothing about Kubernetes. All it is a library for evaluating Rego and JSON files. That's all it is. So there's no inherent knowledge of Kubernetes. It's very much general purpose. So that can be painful, right? It can be a little bit painful. It can make it a bit of onus on the user to define the template properly. There are other Kubernetes policy engines. So the other one I've spent a bit of time with is something called Kubernetes, right? Now that is specific to Kubernetes, and things like this don't happen in Kubernetes. There's no Rego in there. It's actually, I would say it's a bit easier to define policy in that, and issues like this don't happen. I think for a number of reasons, probably just the longevity and also the fact that this is a more general purpose engine. We tend to see OPA out there more, but there's a learning curve around it, and you do have to know a little bit about what you're doing. However, one of the ways you can get around that is that there's actually a really good resource online, which is the Gatekeeper library. So this is part of a Gatekeeper project, just a GitHub repository, and it's got a whole bunch of maintained policies that you can just download and use. So all these different constraint templates that are there, ready to use. They're pretty comprehensive. If you look at the code for some of them, so one of them's here. This is the container limits template. Again, illustrates how difficult it can be to apply Rego to Kubernetes. It's a fairly long piece of code, and all it's doing is just allows you to specify that, one, when you deploy a pod, you must specify limits, and also allows you to specify an upper bound on those limits. However, because Rego, again, there's no inherent knowledge of Kubernetes, there's a lot of code required to get there. So that library is actually a really good resource. And again, another one of those reasons you probably don't need to, at least initially, get too deep into the weeds of Rego and how that works. The last thing I want to cover off, which is actually something relatively new in OPA, and it's still a beta feature, is this concept of mutation. So, everything we've talked about now is around gating, right? So just you try and do something, it's not in policy, so we're going to prevent you from doing it, warn or audit. OPA also and Gatekeeper also have the policy of mutation. What if you just decide that you want something to always be a particular way? And that's what a mutation is. So the example I'm going to use is this one here, where we have a pod that I want to deploy. And in this particular case, I've defined the image pull policy as if not present, right? So it's going to go and pull an image if it's going to go pull the image if the image is not present. If the image is already there, it's not going to pull it again. I don't really want to get into the wisdom or otherwise of a particular policy I'm going to apply, but say for this particular cluster, I don't want people using that setting. I want that to always be always, right? So I could do what I did previously and set up a warning or put a deny constraint on there. The other thing I'm able to do is put a mutation on there, and this is an example of a mutation. So it doesn't use Rego in this case. It's made up of 3 components. It's basically what you want the mutation to apply to, which is this bit here, the scope of application. So in this case, I'm saying across all namespaces with the exception of the system namespace. And then finally, what the mutation is that you want to apply. And you see here that in this case, and we support wildcards and all the rest of them. I'm not going to get into the detail of it too much, but we specify the property that we want to change, and we're going to update that to always. So if I go and apply that particular mutation, so right, so the mutation's there. Now I go and deploy that pod I talked about earlier. Right, so there's my test pod, the YAML you saw earlier with the if not present in there. So that's gone. Nothing, right? I don't get told anything, right? It's just been deployed. And then if I go back to opt-in and just have a look at exactly what's been deployed. Yeah. Where did I put that pod? It's there. There's my pod. I'll check the definition for that. And what you can see there is that, right? It's just silently changed that image pull policy to always. So that capability exists in Gatekeeper. I'm not sure I would use that. I don't like the fact it just happens. You don't get a warning or anything. Personally, would rather put a deny in there. And again, just be warned, it is a beta feature as well. But it is there, and you can use it. So that really is all I want to cover in the demo, right? That's a pretty quick, high-level run-through of all the various capabilities of OPA and Gatekeeper. I strongly suggest if you want to use this, you definitely want to use Gatekeeper, not standard OPA. Much more user-friendly, much more approachable, a lot easier to deploy and manage as well. But it's really straightforward, right? Really simple to get up and running. If you want a list of sensible policies to apply, and there's always a challenge with policy, right? You don't want too much, you don't want too little. What's the right balance? I've got to say that policy library is a really good starting point, right? That's stuff that people use. You do need to go, you're definitely not going to put all of them in there, but you do, you do want to go through that and evaluate those. And I would say a lot of them are applicable to most environments, probes, labels. There's some really good ones around ingresses and being able, making sure your ingresses are sensible. Control of load balancers. If you're in a cloud environment, load balancers can be expensive, right? So maybe you want to put some policy around that. So again, some great examples in there, great starting point. If you're starting out with it, do strongly suggest you start with warnings and audits. Really good place to be, particularly if it's a sort of brownfields environment, and then ramp up that policy. So that's pretty much all I wanted to cover today. Just to finish up in there. So the resources, there's the Gatekeeper project. That's a great place to start. The policy library, as I mentioned before. I should point out is one of the reasons for the popularity of OPA is a lot of organizations, people like VMware, Microsoft, AWS, have incorporated that into their products, right? So VMware, we have a product called Tanzu Mission Control, and one of the things we've embedded in Mission Control is OPA. So it's what you've seen today. The thing we kind of add to that is enterprise level functionality. So the ability to apply policy to large numbers of clusters and do it selectively. So have all my dev clusters with one set of policies, all my production farm clusters with another set of policies. And if you want to give that a try, again, there's a trial and a hands-on lab on the internet as well. And with that, I think we're pretty much right where I thought we'd be in terms of time. So that kind of covers the formal side of the presentation. Happy to keep the session open and cover any questions for anyone online or on the room. I don't think we've got anything in the chat there, but no, I don't.
Hey, Mark.
Hey.
Sorry, go on.
Go ahead, Thomas. Go ahead, Thomas. Ask your question.
Okay, cool. Thanks, Mark, for excellent presentation. So actually, obviously, it's very interesting to manage the policies. My question is in the production, let's say, environments. This is quite interesting where we have to find a team who's actually managing, creating all these policies. Actually, we also have to test it and make sure that we not really affect any production workloads. So my question is here, in your view, what kind of team should be actually responsible, accountable for managing these policies? Is it a platform team or rather actually a security team? What would be the best practice to separate these concerns?
I would say it's a platform team that should be responsible for the maintaining and management of the policy and the application of them. I think they would need to be consulting with other teams. So security is a big one, right? And you'll see a lot of the standard policies are security related. So they definitely need to have strong engagement with security and other stakeholders. In terms of your questions around production impact, and I talked about this, right? It can be a bit challenging applying this to a brownfield environment. So I'd be doing a few things. I'd definitely start off in audit mode. The other thing to be aware of is the audit functionality. The default is that it is going to apply an audit every 60 seconds. In a really large environment, that could be a bit problematic. Like it's the cost of doing that audit is not free, right? So if you have many thousands of objects and you're trying to do an audit every 60 seconds, you run the risk of having the audit exceed that window, and I've seen that cause problems. So, for your first application into a production environment, I would be doing audit only. I'd be winding back those audits. I definitely wouldn't be doing them every 60 seconds. And those audit results are going to give you a really good idea as to what the impact's going to be, right? If you've got red across the board and absolutely everything's violating the policy, that sort of says to you, okay, we got a bit of work to do before we start actually enforcing this. So that's more, sort of a concern on the production side of things. Obviously, your devs and your test environments, you can be a little more flexible, and I'd certainly be looking at starting there in terms of actually applying enforceable policy. That's sort of been what I've seen. I think probably the other thing too is ramp it up, and by ramp it up I mean don't start by putting 57 policies on there, right? Just pick that low-hanging fruit. Go and find those 2, 3, 4, 5 things that are really have caused problems in your environment that are relevant to you, and just start with a limited set and then build them up over time. And that's certainly going to be the least intrusive and disruptive way of getting this applied in a more mature environment where you're introducing this sort of policy for the first time. Does that make sense?
Excellent. Yeah, it makes sense. Excellent. Thank you, Mark. Very informative.
Thomas, some of the other advanced organizations that we have seen in, the platform team sort of owns the platform, but they do get inputs from the risk team and a bunch of other teams. So the platform team is responsible for authoring the policies, but they do get a lot of inputs from the other teams. And if you're following a GitOps principle, there is a possibility that the other teams can also author these policies and would raise pull requests, and it's a platform team which ends up merging these policies into the main line and then push them out into production. So it can be a collaborative effort, but initially generally tends to be the platform team which owns it. And as the organization matures and they understand much more about it, the other teams also jump in to collaboratively author these policies, but the platform team still owns maintaining them into production.
Excellent. Thank you, Pradeep.
Any more questions from anyone? Oh yeah, I see Amit's put in the chat the Rago Playground. Yeah, and that is a really good resource. I did forget to mention that. So that's a I think that's an online tool, isn't it, Amit? So there's a online engine where you can input Rago and evaluate it. And also when you download Gatekeeper and OPA, there's a Rago Playground that you should run on your local machine as well. So, you know, if you want to really get into Rago, it is a bit tricky. It's one of those declarative functional languages that my old C coder brain always has trouble with. So, you know, definitely something you want to spend a bit of time with, and the Playground's a really good resource. Right. I don't think there's any other questions or comments from anyone. Pradeep, did you want to?
I also don't see any further questions. However, team, feel free to add questions to the video which will be shared on YouTube as well as other channels. And we do encourage offline conversations as well. So please feel free to ask questions. And if you have any specific areas that you want to talk to further, more than happy to have this conversation. Thanks a lot, Mark. It was an amazing session. Learned a lot about OPA, Gatekeeper, and policy management in the Kubernetes world, which is a very interesting topic and a very key topic to ensure that organizations are compliant and can manage their regulatory necessities. Thanks everyone else for joining in. I can see that there's been quite a good participation today, given that it's a Friday afternoon and we're just a couple of hours away from 0 o'clock. So thanks everyone for joining. We'll have a next session in 4 weeks from now. The call for papers is open. Please feel free to put in suggestions or join in to present for the next session. Thanks everyone, and looking forward to see you all in the next session.
Thanks, Pradeep. Thanks, everyone.
Thanks, Mark.